Thank you for joining the Once Changing the World, which is India's first Future Tech Meets Sustainability podcast. And today I'm delighted and honored to have with me Mr. Antonio Chella, who is the Professor of Robotics and Director of RoboticsLab at the Department of Engineering, University of Palermo. He's a former Director of the Interdepartmental Center for Knowledge Technologies, Director of the Department of Computer Engineering. He's the author of more than 200 publications and an editorial director of scientific journals, and his interest lies in the fields of machine consciousness, cognitive models of the mind, computational creativity, and quantum AI. Professor Chella is a co-author of ICAR researchers in several scientific publications, and he's involved in the activities of the research group Cognitive System for Robotics, and he's also authored a few books. So Professor, I really appreciate you taking time and being part of the Humble podcast. Why don't we start with a small introduction, your background and the works that you've been doing over the years in the field of cognitive artificial consciousness.
First of all, thank you for your kind invitation to this talk. I am a professor in robotics at the University of Palermo, and I started my Ph.D. on working on neural networks for computer vision, essentially. And at that time, it was in the 90s, essentially. There was no such interest in neural networks, and it seemed to be an interesting argument. And so my PhD thesis was on how to consider a neural network in order to recognize, in order to explain visual scenes. Today, it is a hot topic in AI, in computer science, while several years ago, in the 90s, it was very innovative. It was an innovative line of research, and even at that time, I consider the fact that it seemed to me that something was missed in computer vision systems. So there was a real mismatch between the huge richness of our vision system, of the human vision system, let's say, and the computer vision system was very poor, was very simplified. And then I started to think about what was missing? What is the missing ingredient in a computer in order to appreciate the real richness of the external world? I remember that essentially I attended a conference in Brighton in England, where Professor Igor Alexander, which is one of the founding fathers in machine consciousness, talked about the possibility for a neural network to capture consciousness. So I remember that he had a keynote talk, and he discussed about the possibility of opening the hunting season, so an hunting season for consciousness. It was the first time for me hear of consciousness in relation with a neural network. So essentially, I considered consciousness an argument for philosophers, for psychologists, for cognitive scientists, essentially, but not for an engineer, essentially. While the presentation, the talk of Igor Alexander opened my eyes, essentially, because it was my first time that I heard that neural network, a very simple neural network at that time, was possible. It is possible for a neural network to have consciousness, so to capture consciousness. Then I started to consider this fact, and I also had, starting from this conference, I had many meeting with Igor Alexander. I also invited him in Palermo. I also had the possibility to have honorary degree. The University of Palermo gave him an honorary degree in computer engineer, so we had many connections essentially. But if I have to say what is the person that opened me my mind on machine consciousness was essentially Igor Alexander. And my main interest in this topic was, as I said before, mostly related to the fact that in normal computer science, computer vision system, there is a missing ingredient. Even in AI, essentially, there is some missing ingredients because a system is not an AI system even today is not able to capture the real complexity of the external world. And all the description, all the understanding of the scenes from a current AI system is very sloppy, is very superficial. So it is limited to very simple aspects. So there was no possibility for a computer vision system to really understand what is the complexity of the external scene. So I started my investigation in this topic essentially.
Right. So you mentioned about how the field of AI has evolved over the years, and there was not many people who are looking at the linking neural network to consciousness, and that right now, I think that the field is completely hot right now with the CTO of OpenAI saying the large neural network, GPT-3 is slightly conscious, then the Google AI engineer, Blake Lemon, saying he is an AI, his specialty seems to be in AI bias, and he quoted on the press that, the Lambda model is slightly conscious or conscious, though these are statistical models, and I don't understand how those can be conscious. But yes, we could definitely talk a little bit more about that, and yes, I think it all starts with inspiration and those brave scientists who are asking deeper question, and how you mentioned that how Igor Alexander was that little spark for you to probe deeper into understanding the missing ingredients or the missing links between these AI systems, or how you can make these AI systems understand the external world and possibly build models which we can through language or vision and make those models more aware about the external world. We would get into the consciousness part later, but since you are the head of the robotics lab in Palermo, talk to us more about the state of the art of the current robotic industry, because currently the only robotic company that seems to be profitable is a vacuum cleaner company, Roomba. There is Boston Dynamics doing some amazing work with humanoid robots. There is Engineered Arts who's building amazing robots with Amica. There is Sanctuary AI, which is doing Suzanne Gilder doing really cool things. But they are nowhere close to creating humanoid robots. What is the challenge in building a humanoid intelligent robot first, and then maybe we can talk about consciousness later?
Oh, yes, essentially I agree with you. So the Roomba is in every home. Roomba or similar systems are in every home. First of all, I have to say that we have to take into account the fact that building a serious vacuum cleaner robot is not so simple. So, because if you consider the early Roombas, and in comparison with today vacuum cleaner robot, there is a huge difference, because there is so much technology in today's vacuum cleaner robot. So there are algorithms for planning, there are algorithms for SLAM, which is the localization and mapping. They're able to build the map of the robot, essentially, the map of the house, essentially. So even a serious vacuum cleaner robot is not so simple to do. First of all, I take to consider the fact that building a humanoid robot is very complicated. So I remember the Now experience. There is the Now robot, which is one of the most famous humanoid robot built by now by Aldebaran, which is now SoftBank Robotics, and or the robot built many years ago by Sony. Essentially, there is the problem is the price. So because they are very high price, and it is not so easy for a family to build to buy a toy robot such expensive for children, for example. So who spend $2,000, $3,000, $6,000 for a toy robot at home? So I think that we need the industries need to lower their price to find some new ideas, new technological ideas in order to provide a robot at a lower price, essentially. And the serious humanoid robot today, for example, we have a tight collaboration with Professor Hiroshi Ishiguro at Osaka University, and Professor Ishiguro built the Geminoid robot, so the robots that are so similar to human people. So they are and in fact Geminoid is means robot twin. So the robot Hiroshi Ishiguro built a copy of himself as a robot, but the price essentially is for such a very serious for such a robot is more than $200,000, which is very expensive. It is not necessary having a humanoid robot. However, I think that an important field in autonomous robot is the case of social robot for elderly people, for example. During the pandemic, having a humanoid robot could have been useful because an humanoid robot could give more assistance. For example, could help elderly people to stay at home or for collaboration and so on. And yes, I think there should be some sort of interest in industries to lower their price for humanoid robot. There are no many technological problems in building an humanoid robot. The technological problems are more on the cognitive part, but not on the technological of the technological part of building an external body. I know that even in Italy, for example, there are some experience in, for example, the Italian Institute of Technology built a humanoid child, the ICAB, and I know that in Pisa there are many examples. But today I agree with you that there are no industries which are building real humanoid robots. Let's hope for the future, essentially.
Right. Yeah. So I was not undermining Roomba. The AI architecture behind it is obviously awesome. And you mentioned, how, the way things have progressed. We built a autonomous level, I think level 3 vehicles, and these architectural systems behind these autonomous vehicles are great at understanding the external environment and perceiving it and creating these autonomous vehicles that could drive through, in certain conditions. So yes, there are great things happening. So before getting onto the consciousness part, I would want to stick onto the intelligence itself. What are the current models according to you which are broader enough? Because most of the algorithms or models that we have created are extremely narrow, and they solve a specific purpose. What, according to you, is the state of the art in a model which has a broader intelligence. For example, DeepMind just created Gato, which is supposed to be a multimodal model which does somewhere around 600 or more tasks. What is the current state of the art of an intelligent machine or intelligent model that can do maybe something that humans can do?
Today, I agree with you, there are many interesting implementation of very narrow aspect of AI. And while I'm more interested actually in cognitive architectures that are able to integrate many aspects of the brain. So I have interest in systems like SOAR or ACTAR or the like. So cognitive architecture that are computational model of cognitive architecture that are able to integrate the long-term memory, episodic memory, and perception, action, and some kind of deliberative thinking. So I think that the road toward a conscious machines, in my opinion, pass through the integration of many aspects of the brain. So I know that the GPT-3, for example, or Lambda are very well in simulating some kind of language, but there is something missing. So there is the interaction with the external world. There is missing the capability of touching object or moving or motion. So the sensory motor aspect is important essentially. So this system like GPT-3, like Lambda, lacks this aspect because they don't know the real meaning of the world because they lack the interaction with the external world. So I'm more in favor of systems, and my research is mostly related to what is called the cognitive architecture systems. So systems that are able to integrate several aspects, and the embodiment, and so the sensory motor aspect, the memory system, the perception system, the action system, and whatever. So I'm a roboticist, so I tend to think in terms of embodiment. So I think that the body is an important ingredient for consciousness. So I would be surprised if we discover at some time a real conscious entity which is not embodied, which has not an interaction with the external world. And I'm also interested into developmental robotics, so into systems that are able to develop itself essentially. So to like a child. The fact, the idea to create a baby brain and then let the baby brain develop itself, it's a very old idea. Even Alan Turing talked about the possibility to have a baby brain and then let the brain of a child to develop itself. So, but it is another essential ingredient. So the capability to have a personal history. So a system that is able to interact with itself, to interact with the external world, and then to build a sort of history of itself, and then consciousness and the personality and so on. That depends on this interaction, on the history of interaction with the external world. So I'm more in favor of developmental aspects of robotics. So aspects where the history of the robot is important. I don't think that there are I don't remember any kind of experiment where the robot is on for a long time, for years, for example. I don't know of any kind of. It would be interesting instead to see a robot which is at work or is interacting with the world for 1 year, for 2 years, essentially. So in order to build a sort of personal history, today with robots, we have the same, a robot is like a mobile phone, so after 1 year, 2 years, 3 years, we tend to change our robot because there is a new robot which is more powerful, which are more I don't know, many new features, and then we tend to shut up and to buy a new robot. Well, it would be interesting see a robot that evolve in many years, and also a robot that is able to get old, for example. So no one study about there are no studies on the fact that a robot might become old. So we have problems related with became old, essentially. So I would like to see experiment in considering the working robot for a long time.
If we are trying to reverse engineer the human brain and build a machine which is the artificial consciousness that you're talking about, what would be the approach? Because you gave a little brief on it, brief summary on it, but would you want to expand on that a little bit more?
Essentially, I think that we have to, in order to study consciousness from an engineering point of view, we have to initially take into account to study what are the main features of consciousness. So the feature of consciousness are, for example, the capability of a person to pay attention to something. So attention is a main ingredient. The capability of interaction with other person as another main ingredient. There are other ingredients which are, for example, the capability of having some sort of internal life. So many of us talk to ourselves, for example, the fact of inner speech or internal monologue, or the capabilities of generating mental images, for example, or the capabilities to pay attention to something, or the capability of generate plans, for example, or to having some sort of emotion. So, in my opinion, the engineering the study of consciousness from an engineering point of view is try to indicate what are the main features of consciousness and trying to implement in a robot. And even if all these features are not so difficult to implement in a robot, the real problem is the integration, is the serious integration of all these aspects in a robot. So I think that the real problem from an engineering point of view in creating a conscious robot is to seriously integrate, on the one side is to seriously integrate all these capabilities in a robot, and on the other side having some sort of let the robot to be aware of this fact, so some sort of self-consciousness. So I think that self-consciousness is important, like consciousness. So having the robot capable of, reflect about itself, about its own capabilities, and, for example, a sign of consciousness is the capability of a robot to apologize for some facts. For example, if a robot is not able to perform the task, and the robot is able to explain why it's not able to perform its task, in my opinion, is a sign of self-consciousness. For example, we are studying in the recent years, we are studying the inner speech in a robot. So we proposed a robot which is able to generate some sort of internal monologue, so of the capabilities of the robot to talk to itself. Many of us are able to normally talk to ourselves, And there is a famous movie, many years ago, there was a famous movie of Mel Gibson, What Women Want, or something like this, where the main character was able to hear the thoughts, the inner speech of women, for example. So we are simulating something like this. So what happens if we are able to hear the inner speech of a robot? So a robot that is able to talk to itself, it is essentially a sign of consciousness. Other aspects are the aspects related to the capability of the robot to recognize itself in front of a mirror. This is a very old experiment by Gallup on primates. Only some kinds of primates are able to recognize themselves in front of a mirror. Well, our robot, equipped with inner speech, was able to recognize itself in front of the mirror, because the robot looked at some image in front of a mirror, and then it starts to think about what the robot is looking, and in this way the robot was able to recognize itself in front of the mirror. So I think that consciousness is made up by many ingredients, and the ingredients are we need to integrate all the ingredients we need to seriously integrate all the ingredients, and on the other side to let the robot to be aware of itself. So I think that those are the main ideas related to to our research. For example, as I said before, the capability of robot having an inner speech is important, because many of us normally have inner speech, and this is a sign of consciousness. And so we have to integrate seriously aspects of consciousness. So I don't think that there is only one ingredient in consciousness. It is a complex problem with many ingredients. We have to put together all these ingredients.
Right. So you mentioned, the features of consciousness. I mean, the attention, then interaction, and then what you are approaching, the inner speech. And you mentioned that, through your robot could understand when it was looking at the mirror, the sense of self. So interesting thing. Are there other peers who are working in this direction of creating intelligent machines that you know of? And maybe talk about, this, building, artificial consciousness. I'm sure it's just plain speculation. When do you think we could be able to build, these artificial consciousness? Because you're on the goal to that, right?
Yeah, essentially there are. I'm more interested. For example, I'm interested in the studies, for example, of the group of Hod Lipson, and there are people that recently. There are people that in his lab, Hod Lipson build some kind of robot, which, for example, I remember that many years ago he produced a starfish robot that were able to build an internal model of itself. So the robot was a kind of starfish, and he was able to move mostly by chance. And then by considering the sensory motor interaction with the external world, the robot was able to build a 3D model of itself. Now the group of Lipson built a similar system made up by an artificial arm that, moving in front of the mirror, so similar to our experiment, by moving in front of the mirror, the robot was able to build a model of itself. So those are very interesting studies where the robot is able to build a model of itself. I remember that many years ago, Owen Holland, a researcher, a roboticist from Sussex, built a kind of robot which is a kind of skeleton robot, very impressive, because it was essentially a real skeleton that was able to build a model of itself by moving by chance. So the robot starts to move by chance, and then, considering the sensory motor interaction with the external world, the robot was able to build a model of itself. So I'm looking forward towards systems that are able to start by chance, so differently from GPT-3 or whatever. There are embodied robots that start to move, and considering the sensory motor interaction, the robots are able to build a model of themselves. Those are very interesting studies, and in my opinion, this is the state of the art in machine consciousness systems. And there are other interesting studies, of course. For example, but mostly in simulation. For example, the theory by the information integration theory is another important theory in machine consciousness, in consciousness essentially, and it is very well defined from the theoretical point of view. However, the theory by Anonio and Koch, so the information integration theory, is very difficult to implement in a robot, because there are many problems from the computational complexity point of view. So the idea of considering integration, in my opinion, is an important idea, while their theory is essentially it is at the state of the art. It is not possible to implement them in a robot because of the problems related to the computational complexity. However, it is another interesting view. So.
Right, Professor. So it'll be nice of you to possibly talk a little bit more about inner speech and how does that work in building into artificial consciousness.
Considering our research in machine consciousness, we are investigating the most important aspects, which are the most important aspects, in our opinion, related to consciousness. And one aspect which is strangely is not considered in the research, not only in machine consciousness but in AI essentially, is the fact that we talk to ourselves. So the problem of thinking. So we think, and curiously in artificial intelligence and even in artificial consciousness, the fact that we think, the fact that we talk to ourselves, for example, is not considered a serious line of research. It is only considered in terms of it is one topic in cognitive science, but it's not the main topic. And it's curious because we think, we talk to ourselves, we have, and then it would be an interesting. Instead, it is a very interesting topic of research. And therefore, starting with this idea in mind, we started to study inner speech and in general the problem of how a person thinks from cognitive science. And then we, because we think that a clear sign of consciousness is the capability of a person to talk to itself, about many aspects. There are many theories essentially in concerning inner speech. For example, inner speech is tightly linked to the fact that we have some problems. So when we have some problem, we start to talk to ourselves, for example, or when we look at ourselves in front of a mirror, for example, it is another trigger for inner speech. And or when we hear our name, when we hear people that are talking about us, for example. So there are many interesting triggers for inner speech. Essentially, inner speech, I think that is definitely one interesting aspect for consciousness and for artificial consciousness. Then we started this investigation together with my colleague Arianna Pipitone and another colleague. We started this investigation in inner speech, and we had a tight interaction with one of the main experts, one of the main psychologists expert in inner speech, which is Alan Morin from University of Calgary in Canada, and then we developed a computational model of inner speech, based on a cognitive architecture, as I mentioned before. The architecture, its name is ACTAR, which is one of the main cognitive architecture on the market, so it's freely developed, and it is ACTAR. It is a system that has some block for perception, for action, for memories, and so on. And then on top of ACTAR, on top of a cognitive architecture, we developed a computational model of inner speech, and we implemented this computational model of inner speech on a robot. We have a robot which is a Pepper robot by SoftBank Robotics. It's a very common robot, and then we started to investigate the role of inner speech in human-robot interaction. So we set up some experiments. We had many people that came to our laboratory and interacted with our robot. Then we had some questionnaires in order to understand how the people are reacted in interaction with a robot which is able to talk to itself. Of course, I have to say that we had many problems in setting up this experiment during COVID, because it was not so easy for the people to came to our laboratory to interact with the robot and so on. However, we have 50, 60 people that came to our laboratory and interacted with the robot. And we noticed that the people essentially were surprised to see a robot able to talk to itself. And on the other side, we noticed that the people that consider a robot something like a toy or something very, very robotic in a sense, when they interacted with the robot which is able to talk to itself, they changed their mind. They changed their mind because they consider more anthropomorphic. They consider more anthropomorphic. They consider it more human-like, essentially. So normally people had some views of a robot which is something of robotic from the movies and whatever. When they have too high expectation, like Terminator or whatever. So normally people they did not interact with a state-of-the-art robot. So they are all too low expectation or too high expectations. However, after their interaction with our robot, they changed their mind. So they consider the robot more anthropomorphic, more they like it. It was a very interesting experiment. So because it is essentially a collaborative task, so people have to collaborate with the robot in order to set up a table, like a table for dinner, for lunch or whatever. So they are constrained to interact with people. And the capability, the role of inner speech essentially helped people to better understand what is the theory of mind, let's say. So what the robot is thinking in some sense. So the interaction is more facilitated in some sense. And we noticed in the questionnaire that we employed in order to understand what the people was considering in for our interaction. And it was a very interesting experience. It was a very interesting experience because it is essentially a sign of consciousness. So people as I said before, was surprised to see a robot able to talk to itself, and they consider the robot more anthropomorphic. And this is a good way, the research in artificial consciousness is not only a research line for basic science, in a sense, which is very interesting, of course, because if we are able to build a computational model of consciousness, we will be more able to better understand consciousness itself. So it is a very interesting research line. But it is also interesting also for industries, also for people that are more interested in self-robot. Because if the user, the end user, are more able to interact with the robot, more able to use the robot and to gain values of having a robot, of course, it is an important goal, because we are engineers. So on the one side, we want to investigate basic science, but we also want to help people to use the robot. So we want that the people is able to buy the robot, to build the robot, essentially. So we want also to give a hand to the industries, to the robotic industries. And so the capabilities of for a robot to better explain itself, so to be more, it is more for the robot to be more easy for the user to use, to employ the robot in the right way, is an important goal. So our inner speech robot, in some sense, has been a little success in this way, because the people, normal people, which are not able to see the log or to program the robot, by hearing what the robot is thinking, in some sense, is more able to understand what the robot is doing, what the robot can do, or what the robot cannot do. And so I talked before about the capability of the robot to apologize, for example, which is another sign of consciousness, because when I apologize, when I say, oh, I'm sorry because I'm not able to do it because, and I give some sort of explanation, it's essentially a sign of self-consciousness, because it is the capability of self-evaluate itself. So many aspects of conscious robot, of robot consciousness, are useful not only for basic science, but also for industries. And as I said before, our robot, by using the same mechanisms for inner speech, is able to recognize itself in front of the mirror. And I look forward, for example, for a machine, for a car that is able to think aloud, in a sense, so, or a dishwashing machines or whatever, so, or machine in industries that are able to think aloud, and therefore in collaborative task, this would make a difference. While I understand that if a robot has to do very precise task alone in a completely autonomous mode, the capability for a robot to have inner speech is essentially useless. While in collaborative tasks, where the persons, the user, have to collaborate with the robot in order to reach the task, the capability for a robot to have inner speech may be useful. We had an interesting experiment with a surgeon, for example. We simulated a surgical operation with our robot having inner speech and the surgeon, and the surgeon was very surprised and was very interested in this kind of technology. So essentially, I would like to tell that machine consciousness, robot consciousness is interesting for basic science, of course, but it is also interesting for industries, in my opinion, for the new generation, let's say what is called the new generation of robots.
Right. So, Professor, wish you the very best, because there are people such as yourself who are breaking the paradigm, because you rightfully pointed out, with the consciousness, there are people like, the philosophers who say that the consciousness is the hardest problem, but then there are so many people around the world who are trying to kind of, break that down. That's Michael Graziano, who's got the attention schema theory, and then that you talking about the inner speech. Possibly, maybe we'll come to a point where we will be able to computationally model the future of consciousness first, or possibly understand that what consciousness is, and then maybe someday be able to computationally model it. And I think the day when we do that the world will completely change. I don't even know whether the world is ready for something like that. This is my last question. if in the near future we are able to computationally model consciousness, if in the near future we are able to create artificial general intelligence, would the world be ready for human robot collaboration, co-living? If that is the case, according to you, paint a picture of what the world would look like once, if we have a conscious intelligent robot.
First of all, let's say that the idea of building a conscious robot, so to program, so to have a computational model, constrain, for example, philosophers, psychologists, to be clear, to be more clear on their theories, because there are, of course, many philosophical theories of consciousness, but it is very difficult from these philosophical theories extract a kind of program, a computer program, because in order to program a robot, we need to be very precise, to be all the aspects should be very well considered. And so it is interesting. I have many interactions with philosophers. Many of my publications are with philosophers, of course, and in my laboratory there are philosophers, there are psychologists, but it is useful putting philosophers, psychologists in front of a robot. It is a useful exercise, because we constrain them to be very precise on their theories in order to create a program, a computational program that can be implemented in a robot and see what happens. So artificial consciousness, AGI systems in general, are interesting per se, because they are interesting, because we are engineering and we want to build a new robot, more powerful robot and so on. But it is important even for philosophy and even from psychology, because those people are constrained to think in a computational way, and then to be more precise, to be more sharp about their theory. It's easy for David Chalmers to talk about the hard problem of consciousness or whatever, but of course it is difficult to then implement some programs that falsify or verify this theory. While I look in favor with the idea of Michael Graziano that you mentioned, because the theory of attention by Michael Graziano is a computation. Essentially, it is more easy for a computer scientist to build a model based on the theory of Michael Graziano. And I want to mention for a minute. I want to mention the possibility, the fact that next year in 2023 we are organizing an important conference of consciousness. The TSC, the Science of Consciousness, that normally is in Tucson in Arizona, and for 1 year are in Arizona, and next year will be in Taormina in Sicily, and I am one of the organizers together with Riccardo Manzotti and Pietro Perconti. So next year, and there was a long line of people interested in machine consciousness, including Michael Graziano, that confirmed their participations. And so, coming back to your question, the world is ready for a conscious robot. So maybe tomorrow we have to consider that a robot could have some sort of right. For example, I don't know, but it is normal to consider, for example, that a masterpiece, of an art masterpiece like a painting or a statue has some values per se, as it is necessary to preserve, for example, our heritage, an important painting. And maybe tomorrow it would be, we have to consider the fact that we need to preserve, we need to give right even to some kind of robot. Of course, there are many risks. So people should take into account, all the people should take into account the risks, and therefore the challenge of building a conscious robot should be considered not only in robotics laboratories or in philosophical circles, but it should be a problem that should be discussed by the citizen, by the full citizenships, not only by the expert in the field. Just like biology, for example, and all the problem of genetics or biology. And even robotics should be discussed by all the people, by all the citizens, and in order to reach decisions which that everyone should agree. And I see the risk. For example, a risk is if we build a real conscious robot, the robot should be able to suffer, for example. So we are giving sufferance to an entity, which is an ethical problem, which is one of the ethical problems, for example. Or, for example, if a robot kill one person, what is the responsibility of the robot or the responsibility of the firm that built the robot? Those are not so easy problems. But I think that all the people together, we should be able to start to discuss and to consider this difficult problem. So I would like to see more discussion like the one we are doing, essentially, in order to let all the people, not only the experts in their labs, to have consider and to be updated on this research, on this progress, in order to discuss and reach some kind of conclusion, some kind of lines that we all agree. So I'm more in favor of the dissemination of this research for all the citizens.
Thank you, Professor, for taking time and being part of the podcast and sharing your insights. You're doing some excellent work and your inner speech theory, modeling that and experimenting it with your Pepper robot. You're in the right path of doing some really, really cool thing, and you're challenging the norms, because I guess only an engineer can do that, because there are people who come with a certain structure and mindset, and it's very difficult to break away from that and say that, oh, this is also possible, because I guess the ones who push beyond the impossibility are the ones who create things which will create huge impact. So thank you once again. And yes, you rightfully pointed out, if and when we do happen to build these conscious machines, there'll be lots of pros but there'll be also cons, and for that I think we need to have the larger public participating and understanding about it, and understanding and creating a consensus which is not just driven by maybe a specific nation or a specific group, but the entire world together. Because I guess if and when we build artificial general intelligence, the world could completely change, for the good or bad is something that we'll have to see. But really, really appreciate you taking time and being part of the podcast. Wish you the very best. And to my listeners, if you like what you see in here, then please press the subscribe button. And until next time, see you guys. Bye-bye. Thank you. Thank you, Professor.